This time, we will explain how the world's tallest skyscraper was built. By the end of the 20th century, the race to build the world's tallest skyscraper grinded to a halt. Each new contender was only slightly taller than the one before, and architects were running out of ways to top their previous efforts. But in 2004, construction began on a new building in Dubai, promising a revolutionary design that would dwarf the competition. In 2009, the 828-meter Burj Khalifa was complete, surpassing the previous record holder by over 60%. So what innovations allowed for such a huge leap in height? For most of architectural history, heavy building materials made it difficult for tall buildings to support their own weight. To compensate, taller structures had wider, thicker masonry at the base, making them substantially more expensive. The arrival of industrial steel in the early 20th century helped buildings shed weight and stretch to new heights. But steel frames required intensive labor to produce, often under poor working conditions. And when they were finished, these three-dimensional grids took up huge amounts of space inside buildings. Tall steel skyscrapers also had larger, less dense surfaces, making them vulnerable to strong winds. Architects designed various countermeasures to prevent swaying and structural damage, but to increase height further, engineers would have to completely rethink how tall buildings were designed. Enter the father of modern skyscrapers, Fazlur Rahman Khan. This Bangladeshi-American engineer believed tall structures should bear their weight where they were widest and most stable, on the outside. He proposed swapping an internal grid of steel beams for a steel and concrete exoskeleton that would make buildings more resilient to wind while using far less heavy materials. Khan developed this idea into what he called tubular designs. These buildings had exterior steel frames that were braced with concrete and connected to horizontal floor beams. Tubular frames proved superior at absorbing and transferring the force of wind to a building's foundation. And since the exterior walls could bear the bulk of the load, internal supporting columns could be removed to maximize space. Following the 1960s, tubular design became the industry standard. This new philosophy allowed for the construction of taller, sturdier skyscrapers, including many of the record holders for world's tallest building. But planning the Burj Khalifa would take one more innovation. In 2004, the late Fazlur Khan's longtime employers, Skidmore, Owings and Merrill, completed the Tower Palace 3 in South Korea. This building took Khan's exoskeleton design one step further, with a central column supported by three protruding wings. Each wing's weight carries the other two, while the heavy concrete core acts as a support beam. That also houses the building's elevators and mechanical infrastructure. This design, called the buttressed core, allowed the entire structure to work as a single load-bearing unit, supporting the building's 73 stories. SOM was confident the buttressed core could support a much taller building, and they were determined to see how high they could go with their next project. As only the second building to use this design, the Burj Khalifa spans an unprecedented 163 floors. To battle the monumental vertical and lateral forces, the design strategically places the strongest, load-bearing areas where the wind is also most powerful. Additionally, the Y-shaped layout was specifically calibrated to minimize local wind forces. Every several floors, one of the wings recedes slightly, forming a series of setbacks in a clockwise pattern. This spiral shape disperses air currents, transforming 240 km/h winds into harmless gusts. Considering its height and unique design, the Burj Khalifa was completed in a staggeringly short 5-year period. However, this pace came at a great human cost. The workforce consisted mostly of South Asian migrants, who regularly endured shifts over 12 hours long for a daily wage of roughly $10. Those who tried to quit or return home had their paychecks and passports withheld by the project's construction company. These abusive conditions led to multiple protests, in addition to at least one suicide, and one fatal accident reported on site. In the years following the tower's completion, the United Arab Emirates fell under harsh scrutiny for failing to enforce worker protection laws. Hopefully, future projects will prioritize the individuals behind these engineering marvels over the buildings themselves.